yeah, I think like first we can really start with like what's already there. So you have you used this app stuff there? So yeah, I'll show again. Like so, I saw it. Yeah, you saw the Noir. So like, yeah, sign with Google, and then you can build your generator book. Uh, yeah, and like so in the new version, there is something. So yeah, this was the on stuff phone. Like you can just send a message with someone from yes, yeah. Like this is production, so I'm not sending anything. We have yeah, all many variants also like uh, but yeah, nothing spicy yet. Um, but in like in the new version, I'm just talking about like probing with the email spice. So it is just that dialog version, and you can prove. So this section is for the email, and then this is for the site, and this for the email. Oh, sorry. Yeah, so if you do email, just like it's just one email that I downloaded. Like an email, like any internal company email. So someone from your company send an email to you. You can download that and then open it here. And then take so send to any server. It's just unbrowse it, and you are making a proof. Then in this email, the from address domain and the to address domain are same. So yeah, if we're assuming that on like such an email would be only the company pointing at, and then you can do the same. You can send on the same too.
Okay, will you be able to show us like the circuit?
Yeah, so it will be that. Yeah. So we'll do a Corvo 2 maybe.
Yeah.
Uh, yeah. So I think this file is a good start. Like all the types. Uh, yeah. So this application is like it like made generic. So we have some people anon group, and like if you are signing, like if you are proving you're part of this company, then this company is the unknown.
Yeah.
Yeah, it's like you have there's an ID basically title, and then this is the provider, unknown provider. Um, so in case of Google, like the JWT, there's a provider for that, and for email there is a different provider. So for the front end app, it's like you can have any number of providers, and you can make proofs for any provider. So I'll get to that. So like this app folder here, this is the front end app, and you have these providers here. This is proving up our coordinated email, and this is proving up our water ability. So would you like to explore the libraries of the yeah. So search adaptability. Hmm? Yeah. So well, it's actually dependent on this library.
Yeah, I saw it from me.
Yeah. So like if you go to the main, it takes the data and the keys, and your like the ephemeral public key, main key that's used as nonce. So you are initializing this JWT. This is from the JWT library. We can go to that after this ID, and then you're verifying the signature is valid. Then in the next step, you're like from JWT, you are calling this get plain. So it's like extracting one JSON field. So the JWT library takes care of the interface binoculars and like how to extract field. Once you extract, you're proving that the head of your key with some sort is equal to the value in JWT. Uh, yeah, and there is another like yeah in JWT we are verifying there is a field called email verified and values true. Yeah, because like it's just an extra protection. So if someone creates a Google account and they don't verify the email, they should be able to use it. I think like Google won't even give you sign-in codes, but yeah, in this direction. So then we are extracting the email, get claim string. So most of the core things here.
Here's JSON parser.
Yeah, it's like parsing it's most of the things are happening in the JavaBeauty library before that.
With I'm interested. Why didn't you like list stuff in the unconstrained to choose?
You can. So in JavaBeauty library, it's happening like that.
Okay.
So you are extracting in unconstrained way, and then you're proving it's percent the
Yeah, no, it's not power.
yeah.
Interesting.
So yeah, you get the email, you extract the domain. So okay, so finding the domain index, this is unconstrained actually. So get the domain index. You need to use this break statement. Like you're looking for the ads key, and then like that's the plus one is the domain static text. So you find that unconstrained, and then um, like you're asserting that the value before that is 64. This is the ASCII cap or so yeah, it's where we're setting that the value before the index is set. So like everything after that is the domain. So index plus I, like you're matching the domain that's first. So domain is the public you put here. You can also do extract that and then just do whole return domain. It's the same thing.
Okay. Now, can you show us how you integrate this in the file?
Yeah. So you see this providers folder, and yeah, in each provider you have a JS and you have Noir. In StealthNote, okay, so this is the main front end app. I'm like, yeah, let's go one by one. So let's go to components. So message card, maybe I'll just pieces. So yeah, this blog, right?
Yeah.
There's a message card. Message form is this line, and then the list is the list errorless thing. Promonal, that's this one, and yeah, that's the main thing. So most of the logic is here. If you go to code, register membership, this is the first thing you should do. Like when they click prove and then use one of this method, they are registering. So we'll generate a key pair, then we will get the provider, which provider they're trying to prove with, and then call provider to separate prove. So you see these providers here, they have to implement this method. And yeah, we are calling the server, and server will save everything. And like, yeah, this is the one where you post the message. So sign the message with your key, you're sending the message, and keep it to the server. And the same for verification. So first you verify message signature, then you verify the GK proof, and also happening in the provider. So like most of the things.
Can you go out and just
Sorry,
can you go back to wherever the ready key? Yeah. This one never sending up.
this one.
Yeah, memory. The sign user. Okay.
Yeah.
And then you take this and you send it to the server.
Yeah.
Okay. Where do you send it to the server?
I think this function is coming from this API.
Okay.
So it's just calling API status and sending data.
Okay. And on the server side, can
Yeah. It's Next.js, so so it's like here. So membership, that's like when you register the key for the first time. Yeah, you're verifying the proof with the save provider, and then yeah, using like super-based like Postgres, inserting into a table, and that's such a stroke. Posting a message is here. Post message, you are like extracting. I mean, this is like from the body you get the values, and then you insert in the database. There should be a verification.
But what exactly if you store locally in the database?
So the server is storing all the messages and the proof.
Alright.
Yeah, it can be anything. It can be IPFS. Who has
Like songs.
so
Messages make sense. So it's not really just list.
before that, this is your proof. So you generate the proof once, and then you can send any number of messages with that, right?
Yeah, that's
So the membership registration, that's like you're saving your proof. and like the other API is to submit a message.
Oh, you just said I used this. What exactly do you insert here into database? It says, well, yes, I understand that you need proof and messages probably if you want to show them.
Yeah, so message is here like uh yeah insert it is okay. No. So if we go to so this provider is here, okay.
What's the difference? What's the difference ultimately with this? The group UV provider. Provider is the one that
Oh, yeah.
like controls the domain, but the ID what is?
So in case of the company, the provider is like either JWT or email. So provider is like the code we have here, but the ID is the domain.
Ah, okay.
Yeah.
So the company might have multiple. Let me see.
So this provider, like with your JWT, you can pro for any domains, right? So like that provider is giving like this is the e key for this particular yeah. It's for anyone. Yeah, so if you go to one of these, yeah, like all the providers daily export a JS that implements this interface. That's it. So mainly like generate proof, you will be given the Canberra key, and then you have to return the proof, and it's basically the what's the ID and title of a go. Now you have the save for verify, and then like this is to get the go here. So for example, like this bit, right? Someone from domain name as yeah, that's the unapproved photo. And then you have the get component that returns a React component less than that. So if you click this one, so this bit here, it comes from the email provider, and this is coming from JWT provider. So if you work with JWT, you have the component, right? So yeah, all this info is here. So you have the sign in with Google button.
Last one.
Yeah, and then when you click it, you are loading Google Auth script and then calling the sign in with Google. So this function is implemented here. It loads the pop-up, redirect to Google, and then gets the key and everything. Yeah, so we are so if you semi-mice this. Yeah, get component is we are just returning the component, and in generate proof, you're getting the JWT. From that, you're getting the header and payload, and then yeah, extracting the domain. Basically, you are preparing the inputs for the circuit. So you see all these inputs. This is from our NR file. So everything that's needed for this one, we are preparing from the public key. So the data, the public key, yeah, your domain.
And just like regular
Yes, it's like normal node. So you're importing from back, and then that is probably.
So I have a question. If you would want to add a feature where the same user can't register twice, like with the same email.
Oh, so yes, that would be. I mean, you would need a nullifier for that,
Yeah.
but it's not really a problem for this application because
Yeah, but maybe in the future you want to restrict that. For example, I only have one person from this because maybe you have 10 messages.
yeah,
Sure, that claim me. But if you only have one user, it makes like
yeah. So what you would do is, you would return something like let nullifier equal to, yeah, like hash of let's say SHA-26 of, what is it? Maybe like signature, okay, and then you return this, return nullifier. So this will be like a public input, and yeah, then okay. So if you do a signature, then it's not a nullifier because like it will be sent at a time. So maybe you use something like
the email.
email, yeah. If you do that, it works. Then like the server will see if they have seen the nullifier before. If they have, then they will check it. One issue is that then nullifier is a public input now. So
you can track.
yeah, Google can track it. Yeah, so that's a problem. But yeah, here we are not doing any spam checks or anything like that. So like one person is free to send any number.
Well, so in the future you might have to.
Yeah,
Once we come.
yeah, it's a limitation. Yeah, yeah. I mean, for this use case, I'm not worried. Like maybe if there was like a voting use case, like company internal voting or something, and then you want one person to vote only once, then that's a problem.
Yeah, and because I find like the technical part is like really nice, I think it can be scaled to something bigger.
Yep. What you can do is like you can hash this with some randomness, and
Yeah, like so.
but if this rand is private, then you can
You can always change it.
yeah you can also share it. So
try to do.
there are techniques like OPRF, like uh, shared randomness and all. It's like a general problem to all ID projects, I think.
Yeah.
But yeah, like you can prove that the randomness is coming from some source.
Okay, and if you want to add like a way, for example, to track how many posts this person has,
You cannot. I mean, that's like an anti-privacy breach, I think.
I know, but let's say
So if you have a nullifier, then yes, server can either reject, like if you see the nullifier, you can reject, or like you can say one person can do 10, and then, or like you can simply track comments.
So like, well, if you want to add that, you would rather do it outside of circuit than inside the circuit. If there's no way to do, I mean, you should.
Yeah. For this particular use case, I will do outside of circuit.
Okay, interesting.
Because yeah, I mean, like here there is a trust assumption on the server that it's for onlineness, right? So they have to store the messages. And since because you have the service to free is like service free to define their own span production checks.
Mm-hmm.
So yeah.
And the likes you stored are just in this other.
Oh, actually, that's a good example for nullifier.
Is it?
It's yeah, it's not very accurate now. So I can do this, and then I can clear my local storage, come back and do again.
Yeah, but this was.
Yeah, it's yeah, good example. Yeah, this is one place where you need nullifier. The reason I didn't add this is like you are lacking privacy.
That if you want to preserve your privacy in some sense, what would be another way? Like, you track the keys on the.
There is VOPRF technique or oblivious random bullshit.
Okay.
It's basically this, but it's not something you can change.
Mm-hmm.
Yeah, it will be a private input, but like it will be shared before, and like it's created by multiple people. So yeah, it's used only once.
Sorry, I missed the parts where. So what is the prover the way so that he proves his like we did that, but like there was something mentioned that he received an internal email or something like that.
Oh yeah, that's
Is what's exactly his?
so one way like this circuit is for JWT.
Okay.
The email circuit is here. No, but so is like there are two ways like email e-size piece. So some emails are signed with like RSA 1024 keys. Some are like with 204 byte basically. But it's the same circuit. It's just that the public key limbs it's different. But anyway, like yeah, you're passing the email header. This has all the signed data like yeah subject and from to decaying public key, decaying signature, and then this is where is the position of the from header in your like where is the position of the front key in your do you know like how the events work? Yeah. So position and then like two and then the domain. So we are using the ZKML library to verify the DKM signature. And then yeah, get the from email address. So you're passing the position, and this utility is also provided by that library. You get the address, and then true address. You also get the true address, and then you are verifying. But you're extracting the domain from true address, and then also from address, and then you're matching. They are the same. So if you look here, they're getting the from address, and then okay. So what you do is like we're passing the domain as one public input. Then we are validating the domain in the from address is the same as you passed. So you're extracting the from address from email, getting the index of the domain with the at key, and you're basically asserting all the values after that is same as the input you passed, and you're doing the same for two address. So we are assuming that like if you have an email with from domain and through domain is say you are someone in that company.
Okay, so let's say if I somehow get, like it's forwarded to me an internal email, that would that be enough to prove that? Okay, okay,
It's a limitation.
okay.
Well, if you access someone else's inbox, then yes.
Yeah, okay.
Yeah, no, it's fair. Yeah, there is also like one edge case here. If like if I send email to my colleague, but on the BCC, I could queue, and like CC is signed. So in the circuit you can. Well, I should be doing that here. So you should assert that there is no CC header. But like BCC is usually not signed. So they can impersonate someone in the government. Yeah. The yeah, adding like we can add a new one. Sure.
Yeah, sorry.
Yeah, so it'll be. So you like simple one be people who know the pre-image or some shamash. Yeah, this is like a real example. And
For example, what are some limitations on the WAS on the front end?
on the pendant,
Yeah, for example, when I'm generating proofs on the front end, what are some limitations of circuits that can't work?
yeah, mainly on the circuit size.
Circuits.
So both these email and durability they takes like 10-15 seconds for work. Voice find it.
Yeah. So
Yeah, it's sort of like I don't. Some services like if you want to extract something from email body, then it will be more expensive. It will still work in the browser, but it depends on the email body size. Like for example, one thing I wanted to do for the workshop is like you receive an email from a Duma, like you were instructed for this event. Yeah, you can make a proof of that actually. But for some reason that email didn't have a valid key, I think like their key expired or something. Unfortunately, like in this week they changed their key. But yeah, you can do that. But basically in that case also we just need to extract from the subject, which is cheap. But extracting from email body is expensive.
you can do it around constraints.
If you're doing it unconstrained, then you're not really pulling. So
Yeah, 4.5. So that's good.
so yeah, what you can do is like if you want to extract something at the end of the body, then you get. So you know how SHA works in chunks, right? It was in like some I think like 64 bytes chunks. Yeah. So it's like you hash the first portion, then you hash the second portion, like that. So if you want to extract something from the end, then you can compute the hash up to that block of the circuit and then pass the intermediate hash, and you can continue the. For JWT, I'm actually using that. So this partial hash and partial data. Yeah, they are. So we put this. Yeah, so this they will generate, okay? So this signature is RSS signature of headers and payload. So header is in base 64, payload is in base 64, and then it's image of that. What you want to extract is this email here, right? So you can, and like the signature is you hash all this with SHA-256, and then the hash is signed by us. So you can pre-hash everything up to this key, and that's what I'm doing here. In the JS, if you go, yeah, it's actually in the library. Like you generate the inputs, you are getting, you can pass this pre-commutative key. So up to one of these keys, it will hash outside the circuit, and the result will be the partial hash is this one. I mean the partial hash is this one, and the data that should denote hash is this one. So yeah, whatever you need to extract in the circuit, it should be like hashed with your circuit. Otherwise, you're not probably nothing. Yeah, but this will save a lot of constraints. SHA is like very expensive. To get up.
Yeah. So it is taking 10 to 15 seconds. You must open the camera.
Yeah, it's this is M4 Max, so into something like that. I think like email one must put it past. Let's see.
So the bottleneck is how long the email is, or like
No, so for this one we are not going to the email body. We have this same procurement and too, so it's I think like maybe 10 seconds now. But yeah, for if you want to do like event registration, then if the data you really want to, maybe like the event name that's only in the body, then you need to go to the body. So email signature is like the hash of from to subject, then the hash of the body. So if you want to extract something from the body, you need to do two hash. One the body hash, then you put the hash in the headers, and then you hash that. That's what is signed.
and so in the one where you're only taking from the subject, like what? Like what's in the SIP we're taking all this time? Like
Or mainly to do the SHA verification. So if you maybe if you go to JWT library. So this is JWT library. You need big partial hash. But if you go to verify, you are doing this online here. Getting the SHA. If it's a partial SHA, then you're doing the full hash from the partial input and down. Yeah, you're doing the RSA verification. This is from RSA library.
okay.
As is, like you receive for SHA take size, it depends on the length of the input.
Okay. Yeah.
So
What's cheaper, RSA or PSA? Anyone?
I don't know, but like for this one, like it's the signature is coming from else code, right?
Yeah.
So you had seen also what was that DVC.
See, Noir says it should be cheaper, right? It's doing less computation.
Yeah, I mean like if they're using Poseidon or something, it will be very easy.
Okay.
Yeah.
And so among them, hashtags supported in what is Poseidon the most initiate one, or do you use it?
Yeah, is that Poseidon on Grace?
Sure.
On Octopus.
Okay. Poseidon or what?
That is
Okay.
Usually Poseidon.
Poseidon is still.
Okay. I remember on your GitHub you used to have an airdrop. I don't know, like the airdrop example.
Oh yeah, that's it.
Maybe fixed class nowadays.
Yeah, this is like a example of ZKVO.
Yeah, it was really old because I remember I used it the first time you made it, but then after a couple of months you stopped.
Oh yeah, I don't think I renamed it. Yeah, it's probably with the older version.
Because I think it was the first example of doing article trees that you won, or maybe one.
I don't know if this. Does this have one good way? No idea.
You used to have another one where it had one prefers.
Is that the Stealth Pro?
Yeah.
Bedroom in it.
Now.
Sorry?
Oh, you mean the stealth route?
Yeah.
Zatu?
Stealth.
Yeah.
No, it's best. Yeah. That's it.
No.
There's no plus, no this, Mars, Marlings, slash. Yes.
It's good time now.
Oh no, it's sorry, it's in Noir example. I need to archive that. Small example as because I split, but then Sabio asked me to put it back. So then
Cause I keep the repos like in my notes, and then when I want to go back to them, I see like they're out of like they're not related to what's being done now. And maybe you can walk us through this on the front end and on here.
On the start drop,
Yeah, but it's
you will do.
I can
Yeah. Pero I'm guessing which version of this is.
it's currently being updated actually. You have this project is failing to be.
yeah,
Oh, you tried.
yeah. I tried already.
Yeah. So I can actually make it work. I fixed the thing, but it remember that BBE problem I mentioned in our channel? It said that it was getting unreachable.
Yeah.
It's with self.
Uh,
But like no locally you can build a circuit locally. It's just can't you can expose it on the web.
Yeah, the main issue is with the web also, because I think it's pretty web.
But what I can do is I can push whatever I have now, and you can play with it. But considering that you control the phone on the web, maybe there's something stupid. Of I don't know. Maybe I did not say something. I don't know.
So it'd be nice to see you guys debugging it on live.
And it would be back in life.
Did you try maybe sub shoot once?
Sorry.
Sub using bar. No, no. I mean no current.
I'm using.
But bar, I don't know if it's a.
I didn't say no, but
For browser, it's fine.
yeah. But I'll push what I have into a branch so you can play with it. But yeah, just keep in mind that full file router. There's probably something stupid. And but yeah, I mean I can walk you what I have, but I think you will set outputs right already.
We'll see. Yeah. Yeah, I have to go, but thanks for the screens.
Yeah, I think we are finished up. But yeah, we can, if you want to say, we keep it.
Yeah, I mean, I wrote, so. See you.
See?
Would you guys recommend using your examples, or there was the ZK toolkit? Does that work so? Yeah, it's something like that.
The kits?
ZK kits, ZK kit.
Yeah. It's fine. We are the maintainers for both.
Oh, so okay.
So it isn't.
So I should refer to ZK kit also.
Yeah. It can. Wait, let's find our examples now. Boundaries are already pushed. Yeah, I pushed it. So it should be. Yeah, it's already there. So if you go to the Noir examples, there's a draft PR called pinning to blah blah beta.6. That's on empty scroll. Yeah. I don't know why I pushed it. And I know I'm doing something stupid because like it compiles and it does everything locally. It like builds CLI and fills on the web some. And definitely something stupid I'm doing here. I was in a hurry, so I should check very well.
But it was failing immediately.
Yeah. Yeah, so it's not all or never, it's just valuing. So. But then you guess I'm doing like 100 other things at the same time. Oh, this is right. Oh, you saw it. You saw the job actually.
Yeah, I saw this before, yeah.
Yep, when they took praise the buddies with.
So should we, I think, do you want to see the demo?
Yeah.
Into hundreds. Or non-build, pun build.
They are a button run dash E. Well,
That's massive. Yeah, that was kind of support. Yeah, massive support. Right. Connect. ID walls. Then the so the signature, because it needs to be tuned and there's no wallet that's part tuned, which is a dummy. I mean, it's not dummy. It's just not done on the. So that is the actual signature is actually block signature. It just doesn't. It's not done on the extension. There's actually not signature as support, but it is using this actual tool signature for the dummy address. That source. Well, yeah. Well, it's just them, alright. Okay. Yeah. Also, I have another question. Is like when you do the solidity verifier, does it only works on the VK bytes? Doesn't work on the fields, right? Because I had like one. Yeah. Doesn't work that fields. So when you output the field bytes and fields, and you can use
Yeah, the solidity interface is bytes.
bytes. Okay. But PMBJS doesn't fail when you master fields, and I had an issue like for a couple of days I kept trying to verify.
The profile will get us bytes from their ends. Maybe public inputs?
No, the BK.
Oh, but you don't need to use it.
The BK spins when you want to run it in the front end as well. Yeah.
Yeah. Why?
Lean VKS.
No, like when you generate the solidity verifier,
Okay.
the wiki is already hard coded in the verifier, right?
Yeah.
So you don't need to pass that again.
No, but on the front end when I generate the proof, I have to pass it the JSON. You care.
No. So let's take.
We also made a repo recently for front end. Right?
Yeah. That's it's on scope. Yeah, it's yeah, right. Okay. Okay, so there is okay. If you go back to for example, uh, let's take this one that very my.
Yeah, you see you have the wiki.
Yeah. Oh, I know what you're talking. Not as fields. You want as JSON or something.
Yeah, but when you want to do it with BBJS, you have the right fields.
Yeah, but it's not expecting fields. So
You have like a hidden option or the right DK as fields, right?
yeah.
Yeah, this is what I'm using, and when I do this, I can generate a solidity for verifier at the same time.
But it's not related to solidity, right? You're talking about this one, right?
Yeah.
New quiz. Yeah.
I mean, like I have to generate two of them. One like VK as JSON and a little bit the VK as like bytes.
Yeah. Why do you need the JSON wiki?
I need it for the front end, and then I need another VK for generate verifier. That's all it is.
When you call this one, you are passing the wiki, right?
Yeah.
It's not fields.
Okay.
This is also bytes.
And okay.
Yeah.
So I can use the same file registry formatted.
Yeah. You can like, so if you do BB write VK, you'll get bytes, right? You can read that in Node.js, FS read file sync. Then you can just put here. It will read as bytes. I think maybe it's buffer in Node.js, but
Yeah.
I've converted to unit.
There's also buffers on from there.
Yeah. But like for the front end, you cannot do it first. So in this case, I'm saving as JSON. So if you go to the build script here, you're writing wiki and then you're reading that. It's like I'm running Node.json line. So I'm reading the file, then you indicate care from that, then just like doing JSON stringify and then saving as JSON.
Okay, this is better. Because on the documentation we don't have those slide. There's all this. Yeah.
Yeah, that's something useful for the website. Yeah, it's for frontal unit, something like. It's still not fields at place like bytes per Kanas case. So if you the output is this one, it's
Yeah.
bytes like just a JSON byte.
Yeah, this is the part that was saying.
Okay, mainly because like it's easy to import the JSON, but you don't need to do this. It's not necessary. You can just you like I'm importing it like this, right?
Yeah.
But you can just download also. Yeah. I mean, if it's not JSON, whatever is the raw output from BV CLI, you can just import that. It's just that maybe like they will combine this unknown file type, but it's fine. Like it will be a download, right?
Yeah.
You can see.
Eight. Like maybe you can go through the circuit of the cells. Yeah.
Yeah. I don't really know actually. That way you want to do this?
Sorry.
Going to the substitute or
It is a circuit. Yep. So basically, like
so many other lines. Maybe I didn't do it.
yeah, like there's so many scribbles. Basically, here you need a public key that is out of curve. So it's not BN254. Then we did it. So it have K1 and K1. So basically, you need to use big nums. So it uses in its case 3 limbs to represent the bottom number. So what we're doing here in the beginning is just taking this C and S. They are needed for the tool signature that to generate outside. So the ideal tool signature is like you have a normal ACSS signature and you are able to derive a nullifier, and then you can prove in a circuit that signature could only have derived that nullifier. There's one deterministic nullifier for each signature. So basically you generate the signature, the nullifier outside of the circuit, and you put it inside the circuit inside is C and is S, which are part of this scale field. So you have to get them from a big number. This when you convert these plumes, the conhol it's just like proving that nullifier corresponds to that holy key. So that's how we pass this message. So this is just a verifier, basically just saying yes, that tone is. That's why there's no assertion. We just say tune v2. Let's just say yeah, like it is like you associate, and it just gets you an error if it fails, and nothing if it passes. Just nothing if it's passed. So now that you have a nullifier, basically what you can do is say, if I have a tree of eligible addresses for an airdrop, you basically can say, I can generate a signature from my eligible address, and I can generate a nullifier that is the only possible nullifier for that signature, for this address, for this private key. It's the only possible nullifier I can derive, and basically you can say you can use another address that uses that. So basically you can claim that airdrop with another stealth address. So it's called stealth drop. Like with the stealth address that you create has no relationship to this one. You can basically use that as message sender, and then in the message you send this proof basically. So basically, and then the circuit will verify that, and then basically you just nullify it on another tree. You say, this address that's eligible, it's just nullified. You will never know which address is nullified. Just say that there's no way other address other than eligible address will be able to generate that nullifier. So you get into your privacy.
Where do you save the nullified trait for the bathrooms, for example?
It's probably in I don't know if I actually did it. Like the rest of the team, Go didn't even finish the contract here actually. Probably yeah. No, I don't think I even like finished the ball. This is just quite basically actually like you just you say, oh, I have transferred this token to that, and then Yeah, I would have to have a nullifier tree and just. Oh, actually, there's a. If I'm. Oh, I didn't check for double claims because you're using the same key to generate the pool nullifier because there's no wallet that can generate the pool nullifier. It was using the same key, so you couldn't actually demo. You could only demo once, and then you had to rebuild to these things. No, you don't. So I just returned it. But I made it actually nullify the message center, so you could demo it, but people could just like go and let it spam is a thing. Yeah. But usually you would have like here nullifiers. Instead of putting message center, you would put here the nullifier, and then there's a mapping of nullifiers, and it just checks here no double claim. It checks if the nullifier is already claimed. So yeah, this example is actually ready as far as Toon being ready is because it's binary. I think it's binary. It's internally by ESC, but not the Noir version, and also like it's actually quite useless because no wallet is implementing Toon, and we kind of need another champion to go over this, and because it's kind of a pain to go over to talk with wallets and say, oh, do you want to add to no files? Most of them don't even know it, but yes, it seems sure, never mind. No, yeah, the tool no files. So there's significant like effort from someone that really wants this to be done. Honestly, like I don't have that effort. I don't want to do that. I don't have that energy. And apparently, Ayush, which is the guy that made the tool paper, he also does the art. Like he reached out to MetaMask, he reached out to Talos, reached out to Ledger. I think the only one that allowed it was Ledger. The other ones didn't even care. The MetaMask doesn't even expose. They don't allow communication in their wallet events. It's like couple stages. So yeah. So it's mostly an example. That's why it's in my example. So you don't use these real unused data structure. Yeah, because of that, there are no fires.
So ideally, you want the wallet to generate the proof as well, right?
Yeah, you know, not the proof, but the nullifier. You need the wallet to you need this plume operation to be done by the wallet outside of circuit. I actually explained it. I think not in the circuit, but on the
Yes. So yeah, it's they only need to do the signature on the.
yeah. So where is this? Yeah, I think you're here. I left a comment here, like explaining somewhere. Maybe you spam. I left a comment say like just to make sure on the same page this is supposed to be done by the wall. Somewhere. Then somewhere I left a comment and say use Plume. The Plume signature generation needs to be done by the wall. It's a very small. Actually, it's a basically check the Plume signature repo. Or if you go back to Tahoe or on MetaMask or something, it search for the issues. Or for PRs because they actually implemented it, they just didn't merge it. The change is really simple. The Plume signature itself, it's very simple. You see it in JS, it's pretty fast. Because like the demo actually does this Plume signature, it just does with a dummy private key that's like the hard codes into the website. And that's what I call Vitalik is, which is like just a random key. So that's just to prove that the actual Plume stuff report. So yeah, the only way around it would be to allow people to input the private key into the website, which is a no-no.
Yeah.
So you can make your own extension, or you can make your own extension. Yeah, but people will have to put their private key in that extension, so it kind of goes the same way. Yeah. Yeah. But yeah, I mean it's an example. But the goal is always to be an example. I have another question that's unrelated, but would you guys plan on implementing like provers in what GPU? Is it possible?
Yeah, there's some other people. No, yes.
No, but yes.
Not internally, I think, at least immediately.
Not thoroughly. What's the reason? It's they. I mean, internally they're like, this is gonna change the whole code base to ways in ways that we could even understand. And so they are basically even if someone from the Bratberg team would want to do it, they would do it in a fork. But I know that there's some teams that are doing that, trying to use Bratberg GPU. Obviously, I mean it's pretty massive. Yeah, big thing or change everything. Yeah, but I get that the Bratberg team doesn't want to change anything.
Yes. Yeah, but like once the mainnet is launched, this is what we find.
Will you up and use it? Very interesting. Is there a way to use U1 as a library? Would you use the example?
Oh, like some of the packages can be used as version. Yeah, it was to public, so price, but that's no longer the case yet. But yeah, these things are like super. This is the like I said, what sort of shit? Like, get bring in this guys at similar car. Why would you want that? Like, proving is not happening here, right? Yeah. The pro generation is not here. So this is basically them making a CL for your.
Because I was doing a project university for like an L1 blockchain, so I was thinking, what if I integrate more as like a party versus. Well, on Google there's the Noir which you can integrate inside your normal code.
But in that, you're like, the proof generation is happening there, right? Yeah. Let's say you want to pick a yes, but in Noir, it's not proving anything. Yes. Just like this. So you have to integrate PBJ.
Yeah,
You probably want to use some BB.
Yeah.
There is like a BB.
I mean, yeah, I can do bindings. Yeah, but that would be easier.
Yeah, that's the.
Okay.
In BP there will be like there will be an improvement in the game, like there will be a uniform document that CYs.
Now, yeah, also so you meant that I should do the using So I was looking at the BB because when you do Solidity Verifier points, which are like magical numbers, like how you it log n, there is one of those values, and I was interested to see how it's generated, but it's hard to navigate because it is.
Yeah, so it's
Yeah. So BB needs some documentations. Maybe we need to make it valid for the.
about it can be like that. But yeah, we have a documentation successful to that is on cover the goals for the destinations later meetings. Yeah.